Hi, so this question is reconstruct itinerary. So you're given a ticket 2D string array, and then what you need to do is you want to return the path. So it has to be a valid itinerary. Itineraries means path, right? So how do we start it? We start from JFK, so it must be a port starting uh, the name of JFK, and then we want to traverse. So this is a ticket, so from MUC to LRC, right? So let me just draw the diagram. So this is MUC and then LHR. So from here to here, so this is the path, and JFK to MUC, so this is the path, SFO to SJC, and then LHR and SFO, right? So luckily, like this is a like a straight, right? The straight idea, like you want to start from here, go all the way down to here. So this is the path, right? So what happens if you have a cycle, right? So you want to avoid the cycle, right? Even though you started from JFK and then you want to go over here and then you want to pick either this one or this one, right? So you will just depending on how you do it, right? And let's look at the question. So that has the smallest lexical order, so it has to start from lexical order. So in this question, you can traverse the same spot over and over again, right? So JFK, I'm going to just draw a little bit. JFK to ATL, and then back to JFK, and go up, right? SFO, and then back to here ATL, and then come back to SFO, right? So this is the whole entire path, right? So how do we do this? One straight thing is we need to create a map. So the key is going to be represent the what? The port. So if you did, so if we get the ticket 0, the 0 index represent a port, right? We're going to add, so it's going to be, so we definitely have JFK, SFO, and then ATL for the key, right? And we can have multiple elements on the value in the map, right? And then it has to be lexical order, so it has to be a PQ order, because PQ can be help you to sort it. So I'm going to have a PQ and just add, I'm going to add whatever I have in the index 1 into PQ. So this is actually pretty straightforward enough. So let's do this. Let's create a PQ hash map. So hash map, have a string, and then I have a priority queue. And then what I need to put is a string, right? So map equal to new hash map. So basically I'm going to traverse the ticket. So I'm going to say map.compute if absent, if I didn't initialize this, I'm going to say, okay, I need to initial my priority queue, right? So it's going to be ticket. The ticket get at 0 is my key, right? And this will be my what? The initialize. So new listen, right? And then what I need to do is I need to add a ticket at index 1 into the what? Into the PQ. So the add 1, right? So you can either write 2 lines. One is you initialize a PQ. If you didn't initialize your key yet, right? You need to initialize your value for the map, and then you need to add into the PQ. Alright, so you can do it 1 line or 2 lines, doesn't matter. Now we need to traverse the path from JFK, right? And then later on we need to return a list of string, right? So we need to basically get list result initialize result equal to new array list. So one thing is you don't know how to traverse, right? You don't know. Who knows? PQ knows, right? Priority queue knows, right? It's lexical order. PQ know what is the order, right? And you start it from JFK, then you can just let the priority queue to do it. So public void DFS. And one thing is like if you want to use in DFS, this is important. I'm going to change this later, but I'm going to tell you why this is important. So I'm going to say city, right? So whatever you need to do is priority queue string. So it's going to be PQ equal to new. No, it's not new because we already have the city inside the map. So it's going to be map dot get city, right? So for this one, I have my PQ for the key is what? For the map is JFK, and PQ what do I have? SFO, right? And the next one JFK ATO. So ATO is before the SFO, right? And I have another one SFO. I have ATO, and then this will be ATO and JFK. Another one ATO and then SFO, right? SFO. So this is the entire hash map. And when we want to get the PQ, get a key, so we get a PQ, right? So this is the element, right? And then we're starting from JFK, right? We're starting from JFK, and then we know the next element should be ATO right here, right? So let's cross out this. We're using this one, then we get the ATL to traverse JFK, right? Traverse JFK. Then we get the JFK again, and then we get a SFO, right? And then we get a SFO, we get ATL, and then we get an ATL, we get a SFO. So you want to traverse until it's empty for both. I mean, for all of the PQ, right? So if you remember correctly, JFK is the first element we traverse, right? But if we want to use in the PQ, how do we make sure this is the first one in the list? So here's kind of a trick part. So we're using linked list. We can add every element when we want to code the PQ. So we want to traverse the PQ anyway. So PQ is not empty. And then we want to say DFS PQ at pole, right? We want to traverse until PQ is empty, and then you start adding the city. You start adding the city into the list, and it has to be the first. This is because the last city you traverse is SFO, right? Come on. So the last city you traverse is SFO, right? But your linked list string of result is still empty, right? So you add the SFO into the list, right? And then you recursively back. So this is a recursion, right? So you want to go all the way up when you go all the way down, right? So you know PQ is empty, right? So you break out the value, then you go all the way up. So who called the SFO is ATL, right? So you're not going to add the ATL after. You're not going to do that. You are going to add the ATL in the beginning, which is the index 0, right? So if you prefer using a list, you probably have to say list, result.add index, 0 and then city, and then the whole entire time complexity will be n squared because it's a list, right? If you're using a linked list, you don't care about the time because even though you add in the first one, I mean, the add first function is constant, right? So yeah, let me run it. Hopefully I don't make a mistake. Oh, I do. So map, yeah, map.compute. Okay, okay. Pi. Do I spell this one? Priority queue, stream, something like this. Okay, I will fix that later. Alright. So basically, this is the two line. Alright. Okay, so the time and space is actually v plus e, right? V represent vertices, e represent edges, and yeah, if you want to look at the solution comparing to the author answer, it's kind of same, but not 100%. And the time and space for this one, I don't understand why the time is looked like this, but yeah, if you know the time complexity, leave it as in the comments, and I will talk to I will definitely look at it, and then the space is definitely this. All right, so now I'm going to fix in this. So I'm going to change this to one line. Give me 1 second. Okay, so I forgot this lambda expression. So you need to compute if absent, you need a lambda in x or anything, any letter doesn't matter, an arrow key, new priority queue, get taken. Yeah, this is what I remember. I forgot accidentally. Alright, time and space is still the same. I don't know the time, but space is definitely what b plus e. You need to add every single element into the result for sure. Hash map is stored in, right? So this will be the solution. So if you have question, leave a comment. See you next time. Bye.